Roads to Carbon Neutral, presented by Total Energies. Hello, I'm Emma Crosby. Welcome to the Roads to Carbon Neutral. This series examines how countries, companies and communities have set a clear goal to tackle climate change and achieve net zero carbon emissions by the second half of this century. In this edition, we'll look at wind power, one of the cleanest fuel sources available, and the role it has to play in helping us reach a carbon neutral future. Coming up. As the global wind industry records its strongest year in 2020, we examine how this sector is booming and expanding across the globe.
Together with solar, wind is providing nearly 70% of the world's electricity by 2050.
Reporter Emmeline Nsingi-Nkosi looks at how innovation in wind is helping it become an industry at scale.
I visit a local wind farm project here in Senegal set to provide power to those living off the grid.
And we put wind turbines in the spotlight and see how they keep getting bigger, faster and stronger. First, let's look at the driving forces shaping the role of wind within the energy sector. And to assist us, we've gathered a panel of leading global experts to further understand the role wind power has to play in helping us reach carbon neutrality. As an emissions-free energy source, wind is one of the fastest growing forms of renewable power. The global wind power market has nearly quadrupled in size over the past decade and established itself as one of the most cost-competitive and resilient power sources across the world. Wind power is measured in either megawatts or gigawatts. Megawatts are used to measure the output of a wind turbine, or the amount of electricity required by an entire city. A typical wind turbine is in the range of 2 to 3 megawatts. Gigawatts measure the capacity of large power plants or of many wind turbines, with 1 gigawatt powering between 300 to 700,000 households approximately. In fact, 2020 was the best year in history for the global wind industry. It saw a 53% year-on-year increase. 93 gigawatts of new capacity were installed, which can power some 30 million households. The record growth was driven by China and the United States, who together installed nearly 75% of all new wind farms. While today there are approximately 750 gigawatts of wind power capacity worldwide, helping to avoid over 1 billion tons of CO2. That's equivalent to the annual carbon emissions of South America.
So more than ever before, wind power is seen as a primary contributor to net zero. That latest IEA report, which is compliant with a net zero by 2050 scenario and gives us a 50% chance of reaching 1.5 degrees by the end of the century, has wind as the dominant source of global electricity worldwide by 2050. Together with solar, wind is providing nearly 70% of the world's electricity by 2050.
Wind power deployment will help tackle climate change, but in order to achieve two main targets, sector growth must triple over the next decade. To limit global warming to well below 2 degrees Celsius above pre-industrial levels, a minimum of 180 gigawatts of new wind energy needs to be installed every year over the next 10 years.
So wind is utmost important in our strategy for renewables. As of today, we have more than 1.5 gigawatts of onshore wind facilities. This represents approximately 500 wind turbine generators, so that's quite a big number. But we are not going to stop there. 2 years ago, we have also started developing an offshore wind activity.
We're expecting about 470 gigawatts of new wind power growth over the next 5 years alone. And just to put that into perspective, that's equivalent to around 2/3 of total global wind capacity installed today, which took around 40 years to build and get to this point.
There are 3 types of wind power: onshore, fixed offshore, and floating offshore. Onshore wind is a proven, mature technology which has evolved to unlock more sites with lower wind speeds. An average onshore wind turbine with a capacity of 2.5 to 3 megawatts can supply 1,500 average EU households with electricity. And offshore wind power also offers tremendous potential. Global offshore wind capacity is projected to increase 15-fold by 2040, becoming a $1 trillion industry over the next 2 decades. Bolstered by policy targets and falling technology costs, matching capital spending on gas and coal-fired capacity over the same period.
The development of new offshore wind capabilities is huge because for offshore, you can use much larger turbines. You do not have such limitation as for onshore wind, and you can go to turbines that will be more than 200 meters, more than 12 megawatts, whereas for onshore you only can reach roughly 3 megawatts. You can use floating wind for remote offshore activities where you can have stronger and more constant wind, leading thus to higher generation.
For offshore wind to get more traction, we need to continue to invest in the technologies, in our port facilities, in our vessels for the construction, but also the operation. We need to ensure that the first couple of offshore wind farms that are built in the US are successful, because that will set the stage for a further industry boom.
Exponential growth of the wind sector is expected. However, as an intermittent energy source, improvements in large-scale storage will be needed. Other challenges that lie ahead include how to resource the demand for hardware, the need for engineering expertise, and how to break down the barriers to social acceptance.
We want projects to be accepted by their local communities. We want regulators to ensure that they can permit projects in an appropriate time frame so that society can feel safe that this technology can be used, adopted, and grow.
Wind energy prices will become increasingly competitive as fossil fuel prices rise and wind technology matures. Thanks to innovation in wind power, the global energy industry is truly feeling the winds of change.
It's a huge opportunity for the energy transition, and not just an opportunity, it's really a necessity, one that can't be missed.
Next, Emmeline Nsingi-Nkosi explores where the wind industry is growing across the globe.
It's an incredibly exciting time for the wind industry, and it's truly booming across the globe in developed and developing economies alike.
I am on the way to a wind project situated close to the Senegalese coast to see how millions living off-grid now have access to energy.
But first, let's look at the nations making a mark on the wind sector.
China uses the most wind energy, representing 1/3 of the global wind energy generation, and is home to the world's largest onshore wind farm located in Gansu province. 2020 was a record year for wind power growth in both North and Latin America, with nearly 22 gigawatts of capacity. Wind energy is Brazil's second renewable source of energy, favored by the quality of the winds, which are stable with adequate intensity, supplying nearly 80 million people with energy. Meanwhile, thanks to a long coastline, plenty of wind and government support, the UK has become the world leader in offshore wind, with 35% of the global market share, thanks to over 10 gigawatts of installed capacity. Over in India, wind power generation capacity has significantly increased in recent years and accounts for nearly 10% of India's total installed power generation capacity. In 2020, 821 megawatts of new wind power capacity was installed in Africa and the Middle East, bringing total capacity in the region to over 7 gigawatts, which helps to avoid 10.7 million tons of CO2 emissions annually, equivalent to taking 2.3 million passenger cars off the road. Global skylines will change. The sight of turbines will come to define terrains around the world. In less than 10 years, Total Eren, 30% owned by TotalEnergies, has built a strong portfolio of renewable energy projects.
Total Eren is active on all continents with 3.5 gigawatts of renewable energy assets in operation or under construction in 19 countries, split between solar, wind and hydropower.
This impressive global infrastructure includes over 1.4 gigawatts of wind power, having produced over 1,900 gigawatt-hours of low-carbon electricity in 2020, with new wind farms under construction in Brazil and the Ukraine. In 2016, Total Eren was one of the first European independent power producers to enter Argentina and has 2 wind farms now in operation in Patagonia in southern Argentina. Greece has also become a successful location for Total Eren. Today, the company owns 350 megawatts in operation or under construction in Greece, through more than 20 solar and wind farms spread across the country. We joined the team at the South Evia Island in Greece to get a better view of the company's operations.
In Greece today, Total Eren owns 14 wind farms in operation with a total installed capacity of 265 megawatts. These wind farms are producing annually around 750 gigawatt-hours of low-carbon electricity, enough to save about 500 kilotons of CO2 emissions per year.
Achladotopos wind farm is located in one of the windiest areas of Greece. The site is at the east coast of the island, right in front of the Aegean Sea. It consists of 8 direct drive wind turbine generators, and its yearly energy production is 93,000 megawatt-hours. A greater efficiency and output of the wind farm can be achieved by smooth operations, such as remote control to stop and to start a wind turbine, planning preventive works on days with low wind potential, monitor historical data for alarms. The biggest challenge when operating a wind farm is to ensure a high system availability, especially on difficult weather conditions when most of the faults appear. Regardless of the fault case, my aim is to minimize the response time for repairing the fault and get back to normal operation.
Perhaps it is the most sensitive part in such activities to gain the confidence of the local community. Thanking them for their hospitality, we undertake supportive actions locally, either focused on specific groups who are close to our sites, such as the beekeepers and local cultural and sport associations.
Reaching net zero future requires bold actions from a large number of sectors and stakeholders. Wind power is one of the cornerstones of green recovery, and I believe it will play a very important role in the global energy transition.
Total Eren aims to keep extending its footprint in Greece with plans to develop over 500 megawatts of wind and solar projects throughout the country in the near future.
I'll return later when I reach my destination, the Lekela Wind Farm project in Taibanjai.
Wind power has been used as long as humans have sailed into the wind. For more than 2 millennia, wind power machines have ground grain and pumped water. But modern technology has helped turn this concept into a major energy source. Wind turbines come in many designs, but the most common is the so-called horizontal axis kind, which look like giant fans on poles. This type of turbine is highly efficient at turning the energy in the wind into electrical energy. They've been gaining in size over the years. Today, tower heights are usually in the range of 150 meters. Typically, onshore turbines have blades between 40 and 90 meters long. The larger the radius of the rotor blades, the more wind the blades can use to turn into torque force that drives the electrical generators in the hub. There are 2 basic types of wind turbines. Horizontal axis turbines, which are similar to propeller airplane engines, and vertical axis turbines that have blades that are attached to the top and the bottom of a vertical rotor. The quest for bigger and taller turbines comes with its fair share of engineering challenges. Materials and manufacturing techniques are constantly being refined to create longer and longer-lasting turbine blades.
Wind turbines are designed for a nominal lifespan of minimum 20 years. This is stated in the international standards. In theory, it would also be possible to design them for even more, maybe up to 50 years. The wind industry has sharpened its simulation tools year by year in order to be able to compute the lifetime of each component, even the smallest ones like bolts and nuts under load. If you apply innovation in using better materials, using better design tools, better processes, because engineers and scientists have been very creative and very successful in making blades lighter and lighter and better.
Offshore wind power is having a real momentum thanks to innovation in floating offshore solutions. For many countries, fixing wind turbines to the seabed isn't feasible. Floating structures allow wind energy to be harnessed far at sea and in deeper waters. With this comes a challenge. The further away from the coastline, the more difficult the maintenance and repair of the turbines. Offshore turbines are being built in a hostile environment. The sea's salt water is corrosive, which naturally tries to break down, absorb, or destroy any non-organic elements. To manage them is a major feat. Engineers also have to deal with extreme weather. Depending on their geographical position, offshore wind turbines need to be typhoon qualified, as well as tornado and hurricane proof. Floating turbines can be placed almost anywhere where the water is deeper than 60 meters, harnessing the best wind resources and opening new sites to power generation. TotalEnergies targets 35 gigawatts of renewable generation capacity in 2025, a 100 gigawatt gross capacity by 2030, and a place in the top 5 global renewable energy companies. It's partnering with Principia, which has been working on the offshore projects for 30 years to turn wind into electricity.
There was a natural transfer of expertise from oil and gas to offshore wind and now to floating offshore wind, because there are many similarities between the design of floating offshore wind foundation and oil and gas floater in terms of structure, in terms of seakeeping, of mooring. And then expertise, technical know-how, lesson learned have been very helpful to reduce risk and cost.
Due to higher and more consistent wind speeds, offshore wind farms have the potential to generate more electricity at a steadier rate. TotalEnergies and IFP New Energies are working on a research development program to analyse how floating wind turbines behave and how they can be improved. Continued innovation in this field will be key to producing reliable and efficient wind power on a mass scale. Let's speak now to Grégoire Desèvres, Chief Technology Officer of Offshore Wind at TotalEnergies. Hi Grégoire. Now TotalEnergies has decades of expertise in the oil and gas industry. So what are the technological crossovers that can be used in wind power?
So being an energy major and having oil and gas offshore operations offers several competitive advantages for offshore wind. The main one being that we are used to designing, building and operating industrial facilities offshore in very harsh environments. And the second point being that we have an international geographical footprint. So one key area where we are going to cross-fertilize expertise is in the North Sea. We are one of the major gas operators offshore in North Sea, and this is the main region where offshore wind is taking place.
How do onshore and offshore wind energy capacities and the potential for large-scale power generation differ?
So a typical onshore wind project would consist in 10 turbines, those you can see alongside the road in the countryside. A typical offshore wind project, such as the one we have in Scotland, the Seagreen project, is 114 turbines. The power that can be generated by that project is around 1 gigawatt, and it is a size which is similar to the one you can find in nuclear industry. So it's really gigantic projects.
Gregoire, can you give us a sense of pace of change when it comes to technological developments in offshore wind?
So the main evolution that we have seen over the past decade in offshore wind are twofold. First, it's turbines. Turbines are bigger and bigger in terms of size. We are going further and further off the coast, reaching areas where the wind is blowing stronger and is more stable. The new frontier being floating offshore wind. There is a threshold around 60-meter water depth, beyond which it's not anymore economical to have conventional bottom-fixed foundations. And the new frontier of offshore wind is to imagine how we can put turbines on floating devices. And this is where TotalEnergies in particular is focusing his interest.
And how is digitalization shaping the future of offshore wind power?
Our offshore wind operations will be unmanned. That means that there will be no one full-time offshore to monitor and operate our turbines. The machines, the floaters, the foundations are already full of sensors that would give to the onshore operators the condition of the machines. And the analysis of those information are key to make sure that we properly prepare the maintenance of those facilities. Digitalization has a very large role to play in that matter.
Next, let's check in with our reporter Emmeline Nsinghi-Nkosi, who's on her way to a wind project on the Senegalese coast.
Wind power is a clean source of energy and also one of the cheapest way to produce electricity, making it a viable energy solution for developing economies.
I'm here at Lekela Wind Farm in Taïba Ndiaye, Senegal. It's West Africa's biggest wind farm at scale. Lekela plans to produce much-needed energy supply to the Senegalese and surrounding countries. The wind farm began construction in late 2018 and the project is expected to become fully operational this year in 2021.
Once up and running, it will generate some 158 megawatts of electricity and provide power for over 2 million people.
The project is Senegal's first utility-scale wind energy project and aligns with the government's strategy to increase clean energy production and diversify Senegal's energy mix. I met with Marcel Cissé, General Manager at Lekela, to discuss how the wind farm provides energy security for the region.
Tell me about the project here. What is the scale of this wind farm?
The Parc Éolien Taïba Ndiaye is a 158 megawatt wind farm, so it's a pretty large project by itself. It represents 15% of the country's power production capacity. So it's a pretty important project for the energy mix of Senegal. And in terms of land mass, it is spread out over 60 hectares of land.
The power generated here, how does it fit into the current infrastructure?
This is what we call a grid-connected power plant. What it means is that all the power produced at the wind farm is directly connected to the grid. So we estimated that this wind farm will touch about 2 million people in terms of power production capacity.
How are people benefiting?
The benefit when it comes to power is providing power to people who did not have power before, whether it's a hospital, whether it's a school, whether it's an industry. So definitely a big economic impact in terms of having access to power, but also the social impact of it. This project impacts positively the community that we invest in.
What are the operational challenges you face here?
This being the first wind farm in West Africa and for Senegal, there was a lot of challenges in terms of construction and project management. But that's just par for the course, that's natural for a first of any kind that we're going to run into challenges. But with the help of the government, with the help of our partners like Senelec and the ministries, we were able to overcome all those challenges and build this project on time and on budget.
Here in Taïba Ndiaye, the arrival of the wind farm has meant more than just the facility itself. Lekela makes it a point to invest in the communities they build in.
Lekela's Amadou Sow explains further.
What is Lekela's commitment to this area?
This wind farm is a huge project. It will allow Senegal to enter the renewable energy market.
We have also really invested in education. This IT program is part of many others which try and improve teaching of science in this Taiba and Jai community. Today, there's thousands of students who benefit.
As we have seen, using wind power to provide energy access for people living off-grid can be life-changing. Such is the growth potential for wind as a clean energy solution. A market for small-scale, site-specific power generation is growing. Engineers and tech startups are adapting the shape of the turbine to ensure no matter how remote or unusual the location, it's possible to obtain power.
Vortex Bladeless is a tech startup which has developed an environmentally friendly bladeless aerogenerator. It is a new wind energy technology specifically designed for on-site generation in residential areas, alongside regular solar panels or other generators. For areas with unpredictable wind speeds, instead of propellers, the Magnus vertical axis wind turbine can control its generation in accordance with how the wind blows and adjust to any direction. This improves the cost effectiveness of the turbine, and the slow rotation of the Magnus also offer a less noisy output.
The Magnus vertical axis wind turbine is the next generation of the wind turbine that doesn't use a propeller. Instead of propeller, we can use cylinder, creating the Magnus effect, which is the same physical phenomenon behind the curve ball. By controlling the rotation of the cylinders corresponding to the wind speed, which will then make the wind turbine spin. We're now constructing our first commercialized model in the Philippines, where strong typhoon hit that caused huge loss in economic and human lives. This widespread interest makes us believe that this technology can become a game changer for wind energy globally.
Startups like these ensure that wind power is being harnessed to its full potential.
Well, that's all we've got time for. As we've seen, the growing wind power sector has a significant role to play when it comes to achieving net zero carbon emissions by 2050. If you'd like to find out more, please visit roadstocarbonneutral.com. Thank you for watching, and goodbye.
Roads to Carbon Neutral, presented by Total Energies.